This is the physical science end of year paper, exam paper from 2015, and this is part 1. Let's get in and do question 1. So, just to make sure we're doing okay. So this is question 1. Got my calculator. I've got my current information sheet, pen, pencil in there somewhere as well. Right, let's go. In a bicycle race, the course consists of 3 points that form a triangle. Cyclists commence at point A and ride 7 kilometres south to point B and then 7 kilometres west, so south then west, to point C before returning to point A. So let's have a look here. Never eat soggy Weet Bix, and we'll put some, see if we can't put some of these in. Okay, let's go down from there, and that is going to be 7 kilometres south. Let's go out to there, say, maybe a bit longer. If they're going to be the same length, that is going to be about 40. Let's bring that out to about there. And that is 7 kilometres west, and then they're going back again to the start. Okay. Draw a label diagram showing the displacement vectors for the 3 sections of the course. Well, there you go. And that one we can call distance x, because we don't know what that is. Alright. Show that the distance travelled by the cyclist competing in the course is 23.9 kilometres. So the distance from there to there, let's call that A, B and C. From A to B, from B to C and C back to A is about 23.9 kilometres. Well, we know that A to B is 7 kilometres and from B to C is 7 kilometres, so it's going to be 14. And we can use Pythagoras Theorem to find out what the distance from C back to A is. Okay, so we have got x equals the square root, since a squared, or since x squared equals 7 squared plus 7 squared, so it's going to be equal to 7 squared plus 7 squared. X is equal to the square root of that. So x will equal to the square root of 49 plus 49. 49 plus 49 would be 98, but 49 plus 49 equals, and then we're going to take the square root of answer equals 9.89 or 9.9. Yeah, okay, we'll go with 9.9 equals 9.90 kilometres. Therefore, total distance equals 14 plus 9.9, which equals 23.9 kilometres, which is what we wanted to show. 1 mark. The average speed of the winning cyclist is 40.5 kilometres per hour. So, how long did it take to complete the course? Give your answer in minutes. So if it's 40.5 kilometres per hour and they do 23.9 kilometres, we can find out how much of an hour it is, and then we multiply that by 60 to get the number of minutes. So the distance, we know that the velocity is equal to the displacement over time, because we've got that information here on our sheet for objects travelling at a constant velocity. So in this case, this one it will be, so therefore we're going to find the time, therefore rearranging that, put that one up there, bring that one down there, we get time is equal to S divided by V. Therefore we get time is equal to the distance, 23.9 divided by the velocity, or the speed in this case, 40.5. 23.9 divided by 40.5 equals 0.59. Time equals 0.59 hours, which equals 0.59 times 60, which equals, multiply by 60, 35.4 minutes. 35.4 mins. If you want to convert that into seconds, you can. You just take 0.4 and multiply by that by 60, but 35.4 is going to be fine. Second cyclist stopped 22 kilometres into the race after riding for 32 minutes. Determine the average speed of this cyclist in kilometres per hour. So he's gone 22 kilometres, so it's 14, and it's 23.9 to the end. So he's got to about that point there. And that distance is going to be 7 and 7 is 14, and we're going up to 22, so it's going to be 8 kilometres to that point there. Right, so determine the average speed of this cyclist in kilometres per hour. Well, his speed, or V, is equal to S on T, which equals the total distance, 7 plus 7 plus 8. He's gone 22 kilometres. That's given to us. And he's divided that by 32. Let's go 32.0. And that'll give us in kilometres per minute. And then we can multiply that by, or divide that by 60 to work out. Multiply by 60, sorry. Equals, let's cancel out of that. And we'll go 22 divided by 32 equals 0.6875 hours. So we shall do that will be, which equals 0.6875 multiplied by 60, as we did up here, multiplied by 60 equals 41.25. Sorry, made a mistake here. I was looking at the time, but it's not the time at all. There is my trusty little this time we're looking at the speed. So what we have here is the speed is going to be in kilometres per minute. If we multiply that by 60, then that's how many kilometres you'll do in an hour. There you go. Cool. 41.25, which sounds a bit reasonable. What was his average velocity in kilometres per hour? Well, remember his velocity is going to be his change in position from there to there. Okay, what is his change in position? Over time, I should say. Change in position over time. So his delta S is going to be equal to the distance there, which is going to be, what did we say that was? 23.9 minus 22, which is going to be equal to 1.9 kilometres. Okay, and T is equal to 32 minutes. Therefore, delta V is equal to 1.9 on 32.0. 1.9 divided by 32 equals 0.059 kilometres per minute. So therefore we multiply that by 60 to get equals 3.6 kilometres per hour. Is that the end of the story? No, it is not the end of the story, because I've asked you is the end of the story. Because this is the velocity, you also have to include the direction. Now, because this is a right angled triangle and that's south and that is west, not only is it a right angled triangle, it's also an isosceles triangle, which means that angle in there and that angle in there and that angle is 90 degrees. So these two are going to be equal and they're going to be 45 degrees. So that direction from that point to that point is going to be south 45 degrees to the west. You can either do that, or you can start off by, in this case, start pointing north and then swinging around until you're pointing in that direction. So we would have 90, 180 plus another 45 is going to be 220. So, or 225 degrees. True. And that's the end of question 1.